Hello everyone, and thank you for joining me again for lesson number 29 of the Java Fundamentals stream. So if you are watching the event live, don't forget that you have a live chat there, so you can ask me questions directly in the live chat. If you are watching the event recorded, you can still ask questions in the comments section below, or you can find me on LinkedIn or Twitter and you can ask me the questions there and I will answer you in a separate video or in the next lesson. So we continue the discussion today on exceptions. In the previous lesson we have introduced exceptions, what they are and how do we define them. We know that an exception is a situation that we want to treat somehow differently. This situation is thrown by in a case by a method, and the exception can be propagated as well to other methods in the same calling stack. So we have seen that the that the hierarchy of exception starts with the throwable class, and you have seen that in this hierarchy you have the exception class that's inheriting throwable, and you have the error class as well that's inheriting throwable. Error and exception, they represent situations, but error is the kind of situation that you cannot treat. It's like a, for example, an out-of-memory error, like a Stack Overflow error, no class definition found error. These are situations that cannot be treated by the application, so you generally don't want to get into this kind of situations. So when you refer to an error, or if you define your custom error, it's something that it cannot be treated. You can't define a specific decisional logic to treat that situation. But when you have an exception, exceptions in general are those situations for which that you throw at some point, but for which you want to implement some decision that represents the way your application will treat the exception. So it is the way you will tell your application to resolve that I don't want to say problem, because they don't necessarily are problems, that situation somehow in your code. So sometimes exceptions, yes, they do represent problems, and mainly in those cases we don't treat them, we correct the problems in the design of our code. For example, when you get a null pointer exception, or an array index out of bounds exception, or an arithmetic exception, these maybe are names of exceptions that you recall from the past lessons. We have seen this, but we didn't get into details with them. We will in these lessons that refer to exceptions. These kinds of exceptions that I have just enumerated are generally representing problems of code design, so you won't define logic that treats them. You will basically change your code so that they are not encountered. A null pointer exception, as you know, is that kind of situation when you refer to an attribute or a behavior from something, from some variable that instead of containing the reference to an instance, it contains null. You can't call a behavior or an attribute of something that's null, and that's why you get a null pointer exception. Arithmetic exception is when you divide by 0 to integers, and the integers in mathematics at the integers level, dividing by 0 is not defined, so in case of Java you will get an arithmetic exception, and so on. So when you have this kind of situations, of course you won't treat them, you will solve them, but mainly exceptions represent situations, and in a lot of cases we use them to refer to some specific case that we want to propagate from a method, and generally to be able to solve in another method in the calling chain. So if you have a method A that's calling a method B, let's call it like this, you have A, it's calling B, and then it's calling C, and then you want to have some kind of situation that you can only see when you are executing the logic of this method C. So if here inside the logic of this method you might get into some situation, but you cannot treat it here for some reason, you don't have the enough resources, the needed resources to treat it here, then you let's assume you have it in B, or maybe even in A. Here in A you can treat the situation, but you cannot do that in C. Then the easiest way to solve such a case is, of course, to throw an exception from C and then to treat it in method A or method B or wherever you can do that. So usually we throw exceptions when the situation itself cannot be resolved where it appears, but it can be resolved from one of the methods in the calling chain. If I don't have enough resources, I don't have enough information to treat the exception here, I throw the exception. If B cannot treat it as well, it will throw it further, and at some point, let's assume it gets to method A, and we assume that here in method A we have enough resources, then we do the logic that tells the application how to deal with the exception here in A. So this is mainly the idea of exceptions and the mechanism itself that makes a little bit more easier this kind of situations. Otherwise, imagine if you wouldn't have had exceptions, then the possibility to represent such situations and to throw them to somehow to the methods calling in the chain would have been the return type, but you mainly use the return type anyway, sometimes only to return a value that is produced by the execution of the method. So having also a way to refer to the exception is a little bit more difficult, and decoupling the returned value from what the situation from this kind of situations is actually a good choice and makes our application more maintainable. You simply refer and put them in separate categories. Exceptions are exceptions. The value returned by the method is something else. It refers to the data processed by the method, and it's this way easier to understand the code that you are writing. So exceptions are good. They are a mechanism that is very useful, that I have now told you also these things that very short that we have discussed in the past lesson, but I want to make a little bit of a recap before going to the new subjects. And I want also to remind you that we have discussed that in Java we have two kinds of exceptions that we call checked exceptions and unchecked exceptions, and sometimes the unchecked exceptions are also called runtime exceptions. The checked exceptions are called checked because the compiler checks the exception, and if you didn't provide a way for the application to treat the exception, then the compilation won't work. So you won't even be able to compile your application if you don't provide the decisional solution for that situation. In case your exception is a runtime exception, as you have seen in the previous lesson, lesson number 28, you have seen that this is a kind of exception that is not checked by the compiler. That's why it's called an unchecked exception as well, and it's called a runtime exception because of the fact that if you are allowed by the compiler, you can compile the application, and then you can get into the situation in which you didn't tell the application how to treat the exception, so it will appear at runtime. So that's where the name runtime exception comes from. And when something like this happens, the thread in which the exception appeared will mainly stop, and you will most often you see the stack of the exception, meaning the call chain of the methods up to the point where the exception was thrown. So I would like to start with something like this, very simple, something like like this example, so that we have a bit of recap and we have some exceptions, and then of course the subject for today is how to treat the exception. So I want to start the discussion on the try catch finally block, and I say start the discussion because again it is there is a chance that we won't finish today. So in the hour that we have for the today's lesson, we might have not enough time to finish everything we need to discuss. And the reason for that is because I don't want only to tell you the needed things for your OCP 11. I want to give you the entire picture of everything you need to know for working with exceptions. This is a fundamental part and a very important part in writing Java applications. The exception mechanism is one of the most important parts that you have to understand. So I want to provide you with all the details that you will need whenever you will go to obtain your OCP 11 certification. But as well, I would like to mention and give you all the needed details for working with exceptions. So I would put this objective, actually the first one. From my point of view, it's more important that first you understand all the details that that you require to work and write a clean, good application from the exceptions point of view, and then focus on all the details that you need to know for your OCP 11. And you will see that, as in many other situations, unfortunately from my point of view, in the OCP exam you find details that are rather less needed, but you don't find things that you need the most. And I can give you clear examples on this, and especially on exceptions. For example, you will rarely find resources, and you won't be tested in the OCP 11 if you know where to apply checked exceptions versus runtime exceptions. So I'm not sure why are those kind of things very rarely encountered, but I very rarely find books, articles, and in general material that helps into understanding this. So that's one of the things that I want to discuss with you, and I consider it important, even more important than technical syntax details. So let's say we have a method. I need a method so that I will have an exception of some kind. So I will explicitly throw an exception from the method, and then I would like to be able to treat it. So that's why I'm writing here a public static void m, and this will be my test method, and we will focus first on the syntax, on the basic syntax, but then I would like to give you the details and the aspects of when and where you use it. So I will do like this. Let's assume that I have declared the next, and then what I will do, I will try to divide some integer by 0, and of course you might already know that this will throw an arithmetic exception. Okay, so let's say I have actually 1 divided by 0, and then what I want to do is system out it. And what actually happens, this arithmetic exception is one of the runtime exceptions, so that's why you see no compilation error, and I didn't have to explicitly throw it from the method, because if I have a checked exception, you might recall from the earlier lesson, from lesson number 28, we have discussed that checked exceptions have to be manually propagated. So you do that by using throws in the header of the method, and then you enumerate separated by comma all the exceptions that you use to throw, and you usually do that only for checked exceptions. Syntactically speaking, you can do that, and it will compile for runtime exceptions as well, but runtime exceptions are automatically propagated, so you don't have to do that yourself. But for checked exceptions you have to do that, and we discussed this in lesson 28. So being that the arithmetic exception, maybe it was better to put it like this, is runtime exception, you see here no problem, and then I will be able to call method m right from the main method, because I have defined it explicitly static for this purpose. So what you will see in this case is that on line 10 I will get this exception. So on the line on which the exception appears, like in my case being the line in which the division is done, the exception is thrown, the thread is stopped, and then it will never reach line 11, so you will see nothing printed about x in this case. You will only see the exception happening on line 10, and you will see the stack of exception, which means the chain of methods that have been called one to the other. That means you will see that main has called method m, and on line 10 in method m you have an exception. So you can simply just run it and see the stack of the exception, and then what we'll actually do, we will try to tell tell our application what to do. For example, let's assume that we want on line 6. We would like on line 6 this method to be instructed on what it should do when such an arithmetic exception occurs. So you see the system out print line wasn't reached. Then you have, as we expected, on line 10 this arithmetic exception, divide by 0. This is the message of the exception, and you see the stack of the exception tells you where everything started. So everything started on line 6 because we started the main, and then line 6 is the first line of the main method, which called m, and then further on line 10 we had this exception. So this is the exception stack, which is really useful because it helps you understand where the exception appeared. So in mainly exceptions happen and let's call them throwables, happen in only one thread, and then it's pretty easy to see where it appears so that you can then investigate and correct the problem. Be very careful, however, this is not all the time the case with all the throwables. So for example, if you would have had here an exception for an out of memory error, yes, errors generate exception stacks as well. It's actually, this is a throwable stack. It will be similar for an error. You will see the error like the out of memory error, but you will actually only see the last thread that tried to add something in your heap and could not achieve that, which means that the problem could be from actually another thread. The one that printed the exception might be only the unlucky one to be the last one to try to use the heap memory and observe it's not available anymore and there is no more space, because this is when an out of memory error appears. But generally, and especially when discussing about exception like we do in this case, it's pretty easy because you just in the normal IDEs today, which are very intelligent, you just click on the line and it automatically drives you to the line where the exception appeared, and then it's pretty easy to understand why did it appear and to try to correct the problem. Of course, in our case we did it on purpose, so I will leave it on purpose. What I will actually like to do is change maybe my example a little bit. So instead of system out printing here my value, I would like simply to return the value and print it here, and you will see immediately why I want to change the example to be like this. So this didn't change anything actually. On the first call is the same, so still now the only difference is that line changed to 11, but it's the same thing. The method mem throws on line 11 the arithmetic exception. It doesn't get to the return, so you don't see anything like printed from line 7. And of course, if that would have been an 1 divided by 1, then this doesn't throw the exception anymore. So what you will see, you won't see the stack of the exception anymore. You will actually see on line 7 that the value 1 will be printed in the console, because we just divide 1 by 1, so you will have 1 print in the console. Okay, this is actually important for our next example, because I will go back to having the division by 0, and I would like to assume that this exception happens, but I want something somewhere here in main, especially here where I call the where I do call the method m to offer the application a possibility to treat this exception. And when discussing about treating exceptions, which again means to tell the application which is the decision to be taken when such an exception appears, we use the try, catch, finally blocks. And as you will see, the try, catch, finally blocks can be used together. Some of them can be missing. You will see that in some situations we might only use the try. that is when we have a try with resources. You might even avoid having completely any catch or finally. Generally, when you use a try, you use it together with at least a catch or a finally, or you might use them with all of them all together. And again, what you will see is that you can even have multiple catch blocks. So there are a lot of syntaxes here to discuss and a lot of things to discuss about them when you'll use something like this in practice. So let's start, of course, with the easiest, and then we will try to complicate it and make it more and more complex, the example. So I will use the try, and inside the try block, which is written as you see in my example, we have the keyword try. So this is part of the language vocabulary. It's one of the words like public static void. It's one of the keywords. You can't use it for defining identifiers. It is immediately followed by the curly braces, which are mandatory, and then inside the curly braces you have the block of instructions that might throw an exception. So this is where I expect that an exception might be thrown, and then I can either attach a catch or a finally. You see, if you use a normal try like this, it won't compile if you don't have at least a catch or a finally. But as I've said earlier a little bit, you will see there is actually a situation in which you might have try without a catch and a finally, and that will be when we discuss about the try with resources. I will leave that for one of the end examples, however. So now I focus, and I will start actually with the easiest that I consider of the solutions, and that is use finally together with try. So instead of having any catch, I will only have a try and a finally here. This is not even considered a handle of exceptions, so be careful. This doesn't treat the exception. What is this structure where you have a try and only a finally tells you? Well, the finally block is actually a block of instructions. You see is the keyword, and then again we have the mandatory curly braces here, similar as for try. And this finally represents the block of instructions that are called anytime, even if we have an exception or if we don't have an exception. So this block of instructions will be executed. There are actually two cases in which this finally block doesn't execute. So there are situations that might cause the finally block not to execute. I will come back to this immediately, but you mainly can consider that finally is that block that is executed anytime. So in my case, if I do print something here, then I should see this with or without having an exception. So look, in my case here, I do have the arithmetic exception. I didn't tell the application what to do in case of an arithmetic exception, but I have told the application that anyhow, even if you have an exception, do print the smiley face in the console. So that's what the finally is for here. It is that block of instruction that tells the application to do something more even if it fails. In my case, the thread will stop, like in the previous case where the exception was thrown. It is the same here. I didn't read the exception, but I've told the application to do something more even if I don't have a solution for this exception. So you might wonder, where would you have this kind of a block of try and finally one with the other without a catch? There might be situations in which you don't have a solution for your exception, but you still need to be sure that if an exception appears, still some instructions are executed. There are sensitive instructions that need to be executed, that you want to make sure they are executed. For example, closing connections on the database, they always rely on a finally block. Never write a closing of connection on a database somewhere else. You need to put it on a finally to make sure that if somehow an exception appears, okay, the application will block, the thread will stop, something will go wrong, but the connection will close. So that's really important to achieve, to make sure that a connection to a database is closed. A semaphore, when you use something like this with a thread, that one can be the same, or any kind of a lock object. We will discuss about locks somewhere in the future when we discuss about threads. This is something that needs to happen. Why do I say that it's something that it needs to happen? Why am I so rigorous about this? Well, if you don't close, let's assume the connection to a database is very, very easy to understand. If you don't close the connection to a database, the connections that are allocated by a database management system, let's assume you have an Oracle or a SQL, a MySQL, something, doesn't matter. It is a finite number. You will not get an infinite number of connections from a database server. So you want to make sure that when you open a connection, whenever you've done with it, you close the connection. So what happens if it is that you don't close the connection and an exception causes closing, not closing the connection? So for example, you close the connection somewhere in the try and you don't have a finally, then if the connection is happening here and then you have an exception here, it will never get to closing the connection to a database. So that will happen once, twice, 5 times, 20 times, and at some point, depending on the configuration of your database server, you will have no more connections. So guess what happens when you have no more connections? The application will stuck waiting for a connection from the database and will never get one. It will get into a deadlock, or fortunately, if you have configured the timeout, it will again throw an exception after a timeout, after the timeout itself. There are stories out there where this kind of situation caused companies even millions of dollars. And I recall from a book, one of the stories, well, shame on me, I don't recall the name of the book now. It is, however, an older book. It describes a story from 2000-2001 where an airline had this kind of a problem caused by the fact that the connection wasn't closed properly. So what happened is that the entire system stuck because of the fact that the server didn't allow any more connections to be opened and they had no timeout. Timeouts are also important. We will discuss about timeouts more also on the thread when we discuss about threads. But what happened there is that the application actually was running because it was staying blocked in a timeout waiting for the database to get a connection and never getting a connection. So nobody from outside could see why nothing is working, because the application looked to be up and running, but at the same time the application actually was blocked in waiting connections from the database, and the entire problem was caused by the fact that the connection wasn't closed on a finally block. And because of that, when an exception was thrown, it was actually a coding problem. Let's say assume that the database server allocated 100 connections. After the exception was thrown 100 times, then the system completely got stuck, and it took about 4 to 6 hours to solve the problem. And of course you can imagine what 4 to 6 hours could mean for a company to not be able to onboard the passengers or sell tickets. So a lot of money were lost on this by only a very, very poor design exception. So again, the finally block is the one that you will use whenever you have such an instruction that you want to be 100% sure it will happen, even if you'd have a problem in the code that's executing. So if something happens, I still want to make sure that the exception is that the connection is closed. If an exception happens, okay, the application doesn't work correctly maybe, but I make sure that the database will get its connection back, and then somebody else will be able to use it. Otherwise, I might get into the situation in which the application gets stuck, and the same thing can happen if you have a lock on a blocking object for a thread. There are these kinds of situations. So you see here I didn't run it actually. I will run it. You will see I have the exception. I will see the exception stuck, and then I will see the smiley face. So even if you see that the exception happened and you see this by the fact that you will observe the stack appears in the console, the smiley face is printed, and that will happen with or without the exception. If you change the code now that you don't have the exception anymore, the smiley face will still be there. So the finally block is that one that through which you tell the application, I don't care if you have an exception, you still execute this block of instructions, you still execute this instruction. So the finally will execute if an exception appears, or if it doesn't, it executes in any case. I've said, however, that there are cases in which the finally doesn't execute, and you have to remember that it might happen actually that this happens when system exit method is called to completely close the Java virtual machine instance. We discussed about the system exit method somewhere in one of the previous lessons. Or be attentive for some errors. For example, if you have an out of memory error, it is not guaranteed that the finally block will be executed. So if you get an out of memory error, you will basically see that the finally block is not executed in that case. So there are these two situations in which finally is not executed. I can prove it, at least one of them, the one with system exit. But what I want to do, I've named this class main. Allow me to call it example 1, so that I can have a separate class example 2. And this way I keep the example so that when you will find them afterwards on my GitHub account, you can rerun them yourself. So if I do something like this, if I do try and then I have a system exit, and then I have a finally, then you will see that the smiley face doesn't appear anymore. So when you call system exit and this closes the Java virtual machine instance, then finally is not executed anymore. And the same thing happens if an error is thrown, like an out of memory error. Then in this case there are situations and you might assume that your finally block won't be called. But besides these situations, besides these two situations, you see that's no smiley face here, so system exit caused the finally to not be called. But besides these two situations, in any other case you can assume that the finally block will be executed. So let me show you, even when you have a return in the try block, you will see that finally is executed before the return. So it is a very important thing to be remembered, especially for, then this one is especially for your OCP 11 certification. You won't see something like this usually in practice. I recommend you to avoid it for clean code, but you will find these kind of situations if you attend that OCP 11 exam. So that's why I want to show you this case. So if you have, I need a separate method for this. So I do return, let's say, an integer from my method m, and then I write something like this. I have a try, and then I say return something, and then I have a finally, and then I system out something from here. So you might wonder in this case, would I see the smiley face? And the answer is yes, you will actually see the smiley face. So it might look strange because you might have learned that return is always the last instruction that happens in methods. So when a return is called, nothing happens afterwards. That's actually why Also, if I would have placed this system out immediately after return, I would have had a compilation error, because the compiler tells me if you have a return, nothing after return will anyway be called, so that's an unreachable code. That should be the message here, unreachable statement. So why in this case actually the smiley face will be printed is because when you have a finally, the finally block, it is always executed even after a return. So what happens here is that the return is executed, the value to be returned is kept a little bit more in the memory, and it will be returned in the end by the method, but the finally block will be executed further. So you will see the 10 that will be printed by this line, but you will also see the smiley face that will be printed by this line. So run the example and see that it will be first the smiley face actually, and then you will see the 10 in the console, because first of all the smiley face here was executed, and then you see the 10 in the console. And if you don't trust me, then you can put a breakpoint here and you can execute the debugger, and you will see what happens if you go into the method m. So let's say we step into, you have the return, and then the next instruction that happens is the finally block, and only after this the return happens actually, and then it is printed in the console. So this is expected behavior, and it is the way we expect a finally block to happen. And now example 4 related to this one is what happens if you have a return inside the finally block. So maybe you wonder, can I have two return statements in the same method by putting them one in the try and the other in the finally? And guess what? The answer is yes, you can have a return in try and the return in finally. In theory, and hopefully not in practice. Never do that in a real application. You just have to know this if you want to attend the OCP 11 certification exam, because you will find these kind of questions, and even this exact question was one of it was in one of my previous exams. So if I would like to show you this, I will say example 4, and then I will basically have the same thing. Allow me to do some copy paste programming, even if it's not recommended, and I will say return 10 and return 20. So guess what? It's working. And what do you think it will actually be printed here? Will it be a 10 or will it be a 20? Where basically I think the last value that that is actually returned will be the one that will be kept and basically returned by the method itself. So I expect to see a 20 in the console in this case, which is the last one, meaning the one inside the finally, because finally is executed after the return here. So it will be the return in try, and then you have the finally, which always happens, that will override the value that has been returned from the try block, and that's why you will see a 20 in the console. So yeah, never do that again in a real application. Never do that for your production applications. Never have. It's not recommended, by the way, to have return statements on catches and on finalies, only in try and at the end of the method. But you have to know that this can happen. From the syntax point of view, it's correct. That's what I mean with can happen. So be aware that it's a part of the language, and avoid it when you write applications to make them easy to read. So I think that are actually all the details that you need to know about the finally and using try together with the finally together. We have seen a few examples with this syntax, so we can go now further, write an example 5 and see the next way of working with try catch finally, which is try together with a catch block. Let's see what that means. And example 5 for this. So example 5, and again I would like to have my main method, and again I would like to actually have my method throwing the arithmetic exception. So in order to throw the arithmetic exception, I will divide by 0, and then I will say here try to execute this method, eventually even try to take the value that was returned and print it in the console. And then I will say if you encounter an arithmetic exception, print a smiley face. So what do you think it will happen in this case? Well, we can clearly see that on line 15 the arithmetic exception is thrown because of the fact that I divide by 0. So because of that, the try will call the method and will stop on line 7 in main. Line 8 won't be executed anymore because once the exception appears on one line, everything that's below can't be executed anymore. So it will try to find if I have provided a catch block to treat the exact exception that is thrown. Well, I know that an arithmetic exception is thrown and I have explicitly used an arithmetic exception here. So in my case, the execution flow will find a catch that corresponds to the exact exception that was thrown, and it will execute the block of code in the catch block. So in my case, it will print a smiley face, and this is the only thing that's printed by this current example. Why is it the only thing and I won't see anymore a stack of exception? Because the catch itself, it has the meaning of treating the exception. So it means I'm telling the application that it doesn't have to stack anymore. The thread should continue working, and this is the way you should solve the problem. So this is what I'm telling the application. I'm telling this is how you solve the situation called arithmetic exception. You print a smiley face in the console. So that's why if I run now the example, the only thing that I will see is the smiley face. So you run the example, you see the smiley face, and then I would like to put it back to a value that doesn't throw an exception anymore. And guess what? If you don't have the exception, then the catch block won't be called anymore. So if you don't have an exception and method m simply returns the value 1 in this case and will print 1 here, so 1 will be printed here. But in this case, if I don't throw any exception because I have changed my division here to not throw the arithmetic exception, then you will only see the 1 printed by this line in the console, and the catch block will never be, in this case, executed. The catch block is linked to an exception, and it will be executed only if that specific exception appears. Well, maybe I'm a little bit wrong with my with the way I tell the things. When I say the specific exceptions, I don't actually mean that only arithmetic exception here, because as you will see, the catches respect the polymorphism. So if I would have used here exception or runtime exception instead of this, it would still have worked the same, because the arithmetic exception by means of inheritance is as well a runtime exception, which is an exception, which is a throwable. So even if throwable, it would have worked. But I will get to these details after finishing with the easy examples, okay? So for the moment, I would like to just remember that the catch is linked to an exception, and it will execute only in the situation of an exception of this type. So I will run it again, and we will only see the value 1, which is printed by this line. And you see that indeed value 1 appears in the console, and you don't see anymore the smiley face because we don't have any exception anymore. So it's expected that we don't see the smiley face printed by the catch block. Very nice and clean. If you have a catch, it doesn't necessarily mean that that catch will be executed and that you have treated the exceptions. So don't forget that in the lines that are covered by the try block, you might have different kinds of exceptions that are thrown. So there can be multiple. Line 7 might throw a kind of exception, line 8 might throw another kind of exception. So you might have situations in which you have even multiple types of exceptions that might be thrown from the same block of a try. So if I don't treat a specific exception and that exception appears, it is equivalent to not having at all a catch. So in my case, for example, imagine that I have here the arithmetic exception again. So I'm still playing with this to show you all the needed cases, and I put now back to an arithmetic exception. Maybe it's even better for you. Allow me to copy and create a separate example, because if I don't do so, you won't have then the examples afterwards in the GitHub. So I keep the example 5 as it is, and I start an example 6 for this new example. Well, again, I go here and I have now the arithmetic exception, but I will change my catch to actually treat a null pointer exception. By the way, again, arithmetic exception, null pointer exception, array index out of bounds exception, index out of bounds exception, these kinds of exceptions that represent code design problems, they are not treated, but I use them in this example because it's the easiest way to demonstrate you how try catch finally works. In general, just replace in your mind these exceptions with some real exceptions of your application. I use them like this because it would have taken me too much time to actually define some own exceptions, throw them, and then we would have lost a lot of time for that. So that's why I'm treating null pointer exception, but never ever do that in a real application. But let's now look from the technical point of view. I throw an arithmetic exception, but I catch a null pointer exception. This catch is linked to a null pointer exception. The null pointer exception and the arithmetic exception are totally unrelated. They are horizontal in the hierarchy of inheritance, which means that in this case I didn't actually specify, I didn't tell the application what to do when it gets an arithmetic exception. I have a catch block, but this one is not covering the arithmetic exception. So being that it's not covering the arithmetic exception, what will happen is that the application will stuck on this line 7. Yeah, it will be the thread will completely stop. You will see the stuck exception in the console, and that will show you that on line 15 from method m that was called from line 7 from the main, an exception of type arithmetic exception appears. So see, having a try catch doesn't necessarily mean you have treated all the exceptions. So make sure that when you write a real application, you consider all the exceptions that might appear in your application. So if you consider that you have more exceptions, you have different ways to treat this case. So for example, in my case, maybe the easiest would be to find an exception that is both inherited by null pointer exception and arithmetic exception. So in this case, it will be runtime exception. So if I do replace this with runtime exception, null pointer exception and arithmetic exception are both runtime exceptions. Due to the polymorphism and the fact that a try catch block respects the polymorphism, will execute the runtime exception for the arithmetic exception, because any arithmetic exception by inheritance is also a runtime exception. So you run this, it will print a smiley face, and you won't see the exception stuck anymore in your console. Perfect. However, if you use runtime exception here, you have another problem. Or yeah, depending on your application, you might have the problem that runtime exceptions now refers to absolutely all the runtime exceptions, which means that I have included there array index out of bounds exception, index out of bounds exception, string index out of bounds exceptions, and so on, all the runtime exceptions. And generally, you would like to write in your applications exceptions treated individually. You want to make sure that you have referred to individual exceptions, and it's usually not recommended to refer them by a very heavy parent that incorporates all the other types like runtime exception, exception, or throwable. We rarely do something like this. You prefer to refer to arithmetic exception and use it, be specific on which is the exception that you are actually treating. But if I have multiple, then what are my other options? Well, of course, if you have multiple, you can use multiple catches. So if you don't want to use a parent that has a set of exceptions and you want to treat more exceptions individually, then you can do that. You can have, for example, both arithmetic exception and null pointer exception treated, and you can have as many catch blocks as you want. Just be very careful when you write the catch blocks, and this is important especially to know for your OCP 11 certification. If the exceptions that you specify here inherit one another, so if they are on the same inheritance chain, there will always be written from more particular to the more general ones. So for example, I am allowed here to add another catch for runtime exception, and it will work. It compiles correctly. And what does this mean? If it is an arithmetic exception, then this block will be executed. If it is a null pointer exception, then this block will be executed. And for any other runtime exception, you will have executed this block. But you cannot put the runtime exception before the null pointer exception or the arithmetic exception. If you would try to move this catch above, it will result a compilation error that is unreachable statement again. And the reason for why you have the unreachable statement is because by adding a runtime exception here, being that both arithmetic exception and null pointer exception are runtime exception, it would mean that they are already caught by this block. So these two catches in this case would never be called, and that causes a compilation error. So you can have more catches for exceptions that relate one to the other and are on the same inheritance chain, but when you will do so, you will always have to be sure that you put them in the order from the particular to the more general. So from the children to the parent. You cannot have the parent specified as a catch block before the children. So if you have that, you have a compilation error. You will see a lot of questions in the OCP 11 exam referring to exceptions, and you will even find exactly this situation in some of these questions. So whenever you see that a parent exception is caught before a child exception, it's only a compilation error. The answer is pretty easy and pretty fast. Don't lose time with that question. It's just check the compilation error and you cannot be wrong. And I will end this lesson of today by showing you also the multi-catch, but again to make sure that you will have all the projects at the end in your in the GitHub, and you will be able to run them individually. I will copy this example and make it the last example of today, example 7. And in the example 7, I would like to show you how can you treat individually exceptions but provide them the same block of code. Well, you see, even in my case here, because I have copied, I have the same block of code for this exception and for this exception. And you know that one of the most important principles in writing code is avoid duplication. So of course I don't want to have code written twice. So I don't want duplication of code in my source code. The duplicated code is of course makes the application more difficult to maintain. So how can I avoid, in this case, writing the duplicated code? Well, in my case, being that I actually have the same thing happening for these two exceptions that are unrelated. When the exception, but only when the exceptions are unrelated, you can use this syntax called the multi-catch. So in the multi-catch, you can have two or more exceptions separated by this operator, and at the end you have the identifier that will be the identifier of the exception that is caught, and then the block will execute for either arithmetic exception or null pointer exception depending on what was thrown from the code. So I treat both exceptions individually, but I have the same block of code that will execute for any of them. Syntactically speaking, and referring to Java 11 OCP, so to OCP 11, don't forget that you always have only one identifier, even if you have multiple exceptions referring to in the multi-catch. You will find in the questions syntaxes that are wrong, like this one or this one. As you can see, they don't compile. You cannot have, with the multi-catch, you cannot have individual identifiers. This is not a Java syntax, but you will find something like this in your OCP 11 exam questions. And when you do find something like this, simply again check the not compile response and you won't miss. So don't lose time with such questions. Remember that with multi-catch you can only have one identifier, and again exceptions cannot inherit from one another. So I cannot, for example, have arithmetic exception and runtime exception in the same multi-catch, just because arithmetic exception is a runtime exception. So in a multi-catch you can only use exceptions that are unrelated, they are not on the same inheritance chain. If you would like to have imagine that it doesn't make sense to have arithmetic exception with with runtime exception, would mean that you can simply replace it with runtime exception, because again try-catch takes into consideration the polymorphism. That means that by using runtime exception you automatically incorporate also the arithmetic exception which inherits this class. So this is how multi-catch looks like, and the things that you have to take into consideration when attending your OCP 11 exam. Now I don't have the time, unfortunately, for a new example, but we didn't finish with treating exceptions, so the next lesson will also be about treating exceptions, and I will continue with discussing about using try-catch and finally all together, and then we will discuss all the details you need to know about the try with resources. You will see that try with resources was actually even changed with version 9, so we have differences from 8 to 9 in terms of Java versions. I will tell you when to use them and how to use them, and of course I will give you the the things you need to know regarding when to use checked exceptions versus runtime exceptions, as well as when to use different syntaxes of try-catch and try with resources. Until then, thank you very much for attending, and hope to see you soon for the next lessons. Have a great time for study.